So the quiz tomorrow is going to cover um, a few things. First, parts of the atom. So we've talked about um, the basic construct of the atom, and you've drawn diagrams of them, and I'll do another diagram here just to go over that with you so that you're clear on that. So parts of the atom. The second thing that the quiz will cover is the basic ideas that are related to the rotations that you did in the back. So one of the main ideas is that atoms are very small. So atoms are extremely small. A second idea is that this whole idea of empty space. So we did a couple of simulations, or actually we did the human hydrogen atom model, in which we increased the size of the atom on two different scales. And what we found is that there's a lot of space inside of the atom. So in general, matter is mostly empty space. Okay? So matter is mostly empty space. And then I would say the third idea is this whole idea of big and small being very relative. Big and small are relative terms. Okay? Because when you just think back when you saw Cosmic Voyage, the video you saw last week, and then also at Station 6, the interactive that you and your group worked through, Scale of the Universe. You saw the smallest of the small to the largest of the large. And any of those items, we could look at them and say that one is larger than another, but then there's always something else that's larger than what we thought was big in the first place. So it really just depends on what items are being compared and your perspective. So big and small are very relative terms. As far as parts of the atom go, let's draw out a diagram of the atom. So here's what I'd like for you to do. On a sheet of paper, I want you to draw what I'm drawing. And of course, this is not to scale. All right, and what I've drawn here is the helium atom. And I've drawn helium because I know it has both protons and neutrons, instead of drawing hydrogen, which only has protons but no neutrons. All right, so if we were to label this atom, if I were to ask you to label it, how would you do it? Go ahead and take a minute and do that now. And I also want you to label, I'm going to blow up one of these. I also want you to label what's inside of a proton and what's inside of a neutron. So we're magnifying those. Sorry, my circles aren't very perfect there. So go ahead and draw it, and then I want you to label it. Okay, so at this point, you should have it labeled. So let's see if you were correct. So these structures we're going to call electrons. And I forgot to ask you to put in the charges. So the charge for an electron is actually negative. And in terms of the amount, the charge is -1. So put a -1 by that. Then, of course, this is an electron as well, so it's going to be a -1 also. All right? So inside of the nucleus, we have protons and neutrons. So I'm going to call these two protons. And then these two are neutrons. Helium has 2 protons, 2 neutrons, and 2 electrons. I'm going to write that up here. Okay, 2 protons, 2 neutrons, and 2 electrons. So we're going to call the purple ones are protons, and we're going to call the green ones are neutrons. Okay? Protons have a charge of +1, and neutrons, if you said no charge or 0, then you're correct. Now, I drew these circles as magnified circles because I want us to show what's actually inside of a proton and what's inside of a neutron. So let's start with the proton. So if you said there are quarks inside, then you are correct. And if you drew 3 quarks in there, then you're also correct. But did you draw the correct quark configuration? If this is a proton, then we should have 2 up quarks and 1 down quark. Okay? Let's go to the neutron. A neutron should also have 3 quarks and as far as the configuration, you should have 2 down quarks and 1 up quark. Now, what if you were asked to justify why protons and neutrons have the charges they have? Or why a neutron has no charge, rather? Then what could we say about the charges for the quarks? If we're dealing with a proton, we have 2 up quarks and 1 down quark.
So just know that he was
Sorry about that. Where was I? I was probably talking about the proton. So if you were asked to justify why the proton has a positive 1 charge, then you would need to add up the charges for the quarks. So up quarks we know have a charge of positive 2/3. So there's an up plus another up quark plus a down quark here. So if we have 2/3 plus, and this is positive, plus 2/3 plus negative 1/3, when we add those together, we should get 1, positive 1. Okay, so that's going to be our charge for the proton, and this is how we get that charge because the quarks have fractional charges. Now, if we go to the neutron, can we, in the same way, justify why there is no charge, which is a 0? Well, we have 2 down quarks, so down plus up. So the down quark is minus 1/3 plus a negative 1/3 plus positive 2/3, and if you add those together, you should get 0. Okay, which means that neutrons will not have a charge. Okay. All right. So that's it for the parts of the atom, at least for right now. As we go forward, as we move forward next week and beyond, of course, you'll learn more. But that's it